Greetings everyone. Welcome back to the course Mechanics of Road Vehicles. We are discussing about CO number 4, analyze the tractive characteristics of vehicle for different types of drive. We are in unit number 4, vehicle performance. Our specific outcomes, what we are going to learn here are: determine the power required to propel the vehicle. How much amount of power is actually required to propel the vehicle in desired direction. We have to calculate the amount of power and amount of torque and also the force required to propel the vehicle. Second outcome is analyze the various resistive force act on the vehicle. We know that there are lot or many number of forces that may oppose our movement. In vehicle movement also there are some sort of forces will affect the movement. Here we have to learn the number of forces and the nature of the forces that actually opposes the movement of vehicle. That is we called resistive forces on vehicle. To know the performance of vehicle, it is very important to know the forces and moments that actually act on vehicle. These forces may act in different directions, so that we have to fix the axis system that we are going to follow. Globally, we are following global coordinate system or global axis system. AD point we make it as point O. From origin point, if it's travel from point O to right side, we make it as point X or X direction. From point O upward direction, we mark it as Y, that is vertical direction. Away from point O, we mark it as Z. This is what global coordinate system we generally follow. But SAE vehicle axis system, it's totally different from global axis system that we call SAE vehicle axis system. We mark point O as CG point, we take it as R, rear left wheel center point. I just take rear left wheel center point as point O. From rear left wheel to front wheels, we mark it as X direction. From rear left wheel to right wheel, we mark it as Y direction. Towards downward direction, we mark it as positive Z. I take it as downward. Rear wheel to front wheel, positive X. Left to right wheel, positive Y. Up to down, positive Z. X direction we call longitudinal direction. Y direction we call it as lateral direction. Z we mark it as vertical direction. So that in vehicle axis system of SAE we mark rear wheel to front wheel longitudinal direction, left wheel to right wheel lateral direction, towards downward direction vertical direction. For understanding, I just make vehicle axis system in picture. Here I took CG as center. From CG towards front wheel I take it as longitudinal direction. Towards right wheel I take it as lateral direction, and downward take it as vertical direction. These are positive. Opposite sides are negative. Forces on tire or tire axis system. Let me take a tire like this. To describe the forces and moments acting on the tire on wheel, one of the commonly used axis systems which is recommended by the Society of Automotive Engineers is vehicle axis system. Here we took CG point as center or origin point. Towards front wheel we take it as positive X, that is longitudinal direction. Towards the right wheel positive Y, lateral direction. Top to bottom positive EZ, that is vertical direction. This vehicle axis system is used in tire. So it becomes tire axis system to describe the forces and moments acting on tires on wheels. Let us take tire center point here as O. This tire is moving on road surface. Let me take a road surface like this. I just take this road surface as X axis, that is longitudinal direction. You know that very well. Let me take it as X. This tire has a wheel torque at the center of wheel, so it may rotate in clockwise direction so that the vehicle will move like this side, like this. So I just mark it as in aura point. Vehicle will move in this direction because of clockwise rotation of wheel torque. Let us take vertical axis as Z. You know that, and lateral axis as Y. I just mark here again. There may be three directional forces may act X, Y, Z. The force act on X direction may be like this. I just take it as Fx. If the force act in Y axis or Y directional axis may be like this. So this X direction force Fx is longitudinal force. So this I just take it as Fy. I just write here Fy. So this is called as lateral force because of the force act in lateral direction. If the force act in vertical direction, so we mark it as Fz because it is Z directional force, Fz, which is called as vertical force. There may be number of moments act on tires or wheels. First one, moment along x-axis, moment about x-axis. Maybe like this. It is rotating in anti-clockwise direction. Here you can note. So it is in anti-clockwise direction. We have to look at it from origin side. If you look this direction of force from origin, so it looks like anti-clockwise direction. I take it as mx because this moment along about x axis. Mx, this moment is called as overturning moment. If the moment anti-clockwise direction about y-axis, I just mark it as my. This is called as rolling resisting moment. Moment about z-axis in anti-clockwise direction, we just mark it as mz, which is called as aligning torque. There are two important angles associated with a rolling wheel. These include the slip angle and camber angle. Slip angle may be indicated as theta or phi, whatever, and camber angle may be indicated as gamma. These two things are very important in terms of tire axis system, but we can discuss these angles and the influence of angles on tires and vehicle performance in our future sessions. Power required to propel the vehicle. Here we can find two power availability. One is engine power, another one is power available at wheel. Engine and wheel. Here the power required to propel is the power available at wheel. That is what used to propel the vehicle. I just take it as PW. We know that commonly power is equal to 2 pi nt by 60. Here indicates speed or rotational speed of component in RPM. T indicates torque in Newton meter. And also we know that torque is equal to force into distance. Here you can note the wheel torque is equal to the force used to move the vehicle into distance. So that the distance to move the vehicle here required to the force is R, that is radius of tire. We can take radius of tire as R. Here the wheel torque is equal to, that is force required to move the vehicle into distance, that is R. The required amount of force here is resistive force. So I just take resistive force as R, caps R into radius of tire small r. Caps R is resistance, that is air rolling gradient. These three resistance combinedly gives total resistance, that is equal to R. Small r indicates radius of tire. So here torque is equal to resistive force into rolling radius. The power can be written as P equal to 2 pi n into force into distance divided by 60. P is equal to, instead of force we take our distance, we take small r. 2 pi n by 60, we know that omega equal to 2 pi n by 60. I take it as omega into caps r into small r is equal to power required to propel the vehicle. We know that r omega, that is Angular velocity and radius of rotation is equal to linear velocity. V equal to r omega, so that P is equal to r into V. Here r indicates the resistance, V indicates the velocity. P in watts, that is power in watts, r is resistance in Newton, small r is radius of tire in meter, V velocity in meter per second. If you want to calculate the power available at wheel or that is required to propel the vehicle in kilowatt, we can calculate by P equal to RV by 1000, which gives the value in kilowatt. Here we have to apply the resistance in Newton and vehicle velocity in meter per second. If you want to apply the resistance in kilonewton, we just make it as RV by 3600, which gives the value in kilowatt. If you apply the resistance in kilonewton and vehicle velocity in kilometer per hour, you can use this formula. In all the books you can find power required to propel the vehicle is equal to RV by 3600, which gives the value in kilowatt. This formula is also right. P equal to R into V. Here you get value in watts. R you substitute in Newton. V velocity in meter per second. If you want to calculate it in kilowatt, you can divide it by 1000, which gives the values in kilowatt. If you want to apply the resistance in kilonewton, vehicle velocity in kilometer per hour, you can use this formula, which gives the values in kilowatt. You can use anything.